Okay, now I want to do an example of regression, and I'm going to jump right into an example. So for the following data, find the regression line or the regression equation, and with significance alpha equals 0.05, find the y value when x equals 6. To be honest, that find, the correct word there would be predict, not find. Okay, predict the y value when x equals 6, and I'm going to get a set of points. Keep this simple, 1, 2, 3, 4, 5, and the y values, let's make it 12, 10, 7, 5, 3. Okay, so there's my x and y values, and I'm going to start this out by putting these x and y values into list 1 and list 2. So I'm going to start with a stat, and I'm going to clear out whatever I have in list 1 and list 2. So clear list, there's L1, comma, L2. Okay, the lists are cleared. And now I'm going to go to get the regression equation. I'm actually going to go to stat, tests, and down to lin-reg t-test, which is the same thing we did for the hypothesis tests when we did correlation, lin-reg t-test. So I'm going back. Oh, wait a minute, did I enter the points? Oh, wait a minute, timeout. I cleared out the lists, but I don't think I put the correct numbers in, so let me go back and do that. So I'm going stat, edit. Yeah, I cleared out the lists. Okay, sorry. 1, 2, 3, 4, 5 into list 1. And then in list 2, I'm putting 12, 10, 7, 5, 3. Well, I would have found out it would have given me an error when I tried to do the lin-reg t-test. Okay, now, after entering the numbers, I'll make a comment about that. Entering the numbers, x goes to list 1, the y values go to list 2, then I'm going stat, tests, lin-reg t-test. So I'm going stat, tests, and I'm arrowing down to lin-reg t-test. There it is. And this is the one that we did when we did the hypothesis test for correlation. So we want actually the same exact way we had it before. The x list should be L1, the y list should be L2, the frequency is 1, this beta and rho not equal to 0. The regression equation, y1, you can have that in there or you don't have to have that in there. I'll leave it in there. And then when I hit calculate, see, it gives me the regression equation. The regression equation is denoted as y equals a plus bx. And it gives me the value of a and b here. So there's the a is 14.3 and the b is negative 2.3. So a is 14.3, b is negative 2.3. And so the regression equation for these data is y equals 14.3 minus 2.3x. That's the regression equation. Now, when we use this to predict the y value, there's a little bit of an issue where, remember, it said use significance alpha equals 0.05 in the beginning. That has to do with this p-value here. Notice the p-value. Notice the p-value was 1.80 times 10 to the minus 4. 1.8 e minus 4, which is like 0.00018. So notice that that's less than 0.05, is less than 0.05. That means there is linear correlation. And for the purposes of regression, that means we can use the regression equation to predict y. Otherwise, what you would do to predict y would be to just take the mean of the y values and use that. I'm not going to give you an example like that. There's not an example like that in the homework, so I don't want you to worry about that. So remember, we're using the equation y equals 14.3 minus 2.3x. And the question asked to predict y when x equals 6. So what I'm going to do is take that equation, there it is again, 14.3 minus 2.3x, and instead of x I'm going to put in 6. 14.3 minus 2.3 times 6, and then I'll use the calculator for this. Let's get out of there. 14.3 minus 2.3 times 6, and I get 0.5 for that. And that would be the predicted value of y when x is equal to 6.